Imagine a tiny world drifting silently through the cold darkness of space. A glowing trail of dust and ice stretches behind it, shimmering like a silver ribbon under the light of distant stars. It moves slowly, gracefully, carrying secrets that are billions of years old. These are comets, the cosmic wanderers of our solar system. Comets are more than just bright streaks in the night sky. They are time capsules, frozen messages from the birth of our solar system. Within their icy hearts lie the building blocks of planets, the ingredients that may have helped life begin on Earth, and the whispers of distant stars beyond our own. Every comet that visits our inner solar system tells a story written in ice, dust, and fire as it reacts to the warmth of the sun. Some comets return faithfully, like Halley's Comet, appearing every 76 years. Others arrive from the farthest edges of space, from clouds of ice and rock that orbit silently in the dark, unseen for thousands of years. And sometimes, a comet comes from far beyond our solar system, a stranger carrying mysteries from another star, challenging everything we thought we knew about these frozen travelers. As we watch a comet streak across the sky, we are not only seeing a celestial object, we are glimpsing a journey that began long before Earth existed. Each tail, each glimmering coma, each subtle curve in its path holds clues about our cosmic origins. Some glow softly in white and yellow dust, while others shimmer in a ghostly blue sculpted by the invisible breath of the solar wind. Yet, despite all our science and observation, comets remain elusive. They change with every pass near the sun, erupting in jets of gas and dust, breaking apart in ways that remind us of their fragile, transient nature. Some carry water, others complex organic molecules. Some may even hold answers to questions we have not yet imagined. Tonight, we will journey with these silent travelers. We will follow their long, winding paths from the distant reaches of space to the inner warmth of our solar system. We will explore the mysteries they hold, the secrets they have kept for billions of years, and the strange, beautiful phenomena they create in the night sky. If these relaxing stories spark your curiosity or help you rest, don't forget to like and subscribe to be part of our nightly journeys. You can also leave a comment below. It's a simple way of helping other curious minds find this space too. As we begin, let your mind drift with the comet through the quiet, infinite stretches of space. Imagine the icy surface, the glowing tail, and the silent drift across a dark canvas dotted with stars. Listen to the story that has traveled billions of kilometers to reach us, a story of cosmic time, fragile worlds, and the endless dance of matter and light. And perhaps, as we look closer, we may begin to understand why comets are some of the most fascinating, mysterious, and beautiful objects in the universe. As our journey continues, let us look closer at the structure of a comet. At first glance, comets may appear as simple glowing dots or streaks of light in the night sky. But if we could approach one slowly, floating beside it in the silent vacuum of space, we would discover a complex and fragile world, a tiny laboratory of cosmic material shaped over billions of years. At the heart of every comet lies the nucleus, the solid core. This is the true body of the comet, usually only a few kilometers across, yet it carries within it the ingredients that formed the planets. The nucleus is composed of ice, dust, and tiny rocky particles. It is hard, but not very strong. Comets are fragile, more like a clump of frozen sand than a solid rock. If a comet passes too close to a planet, or even to the sun, the forces can break it apart. Some comets have even split into multiple pieces, drifting slowly apart, each fragment carrying part of the original story. The ice within the nucleus is a mix of water, carbon dioxide, ammonia, and other frozen gases. These ices are like tiny time capsules, storing the chemical history of the early solar system. When a comet is far from the Sun, these ices remain frozen, and the comet drifts silently, almost invisible, like a ghost in the darkness. It is only when the comet begins its journey closer to the Sun that its hidden wonders reveal themselves. As the Sun's warmth reaches the comet, something magical happens. The ices on the surface begin to sublimate, turning directly from solid into gas. This gas forms a glowing cloud around the nucleus called the coma. The coma can grow to thousands of kilometers across, surrounding the tiny nucleus in a soft, luminous haze. It is in this cloud that most of the comet's visible beauty comes to life. Dust particles, released from the sublimating ice, scatter sunlight and create the familiar shimmering glow. The coma is fragile and constantly changing, shaped by the Sun's energy and the comet's rotation. From the coma, streams of gas and dust are pushed outward to form the comet's tails. Most comets have two distinct tails, each with its own character. The first is the dust tail, made of tiny solid particles. This tail is curved and often glows a warm yellow or white. It follows the comet's path, gently bending along the curve of its orbit. The second is the ion tail, made of charged gas particles. The solar wind, a stream of charged particles emitted by the Sun, pushes this tail straight outward, forming a bluish, ethereal beam that can stretch millions of kilometers. Watching both tails together is like seeing two rivers of light flowing from a distant, wandering world. The surface of a comet is not smooth. It is covered with craters, cliffs, and pits. These features form as ice and gas erupt from beneath the surface, creating jets that shoot into space. Sometimes these jets are small and gentle, forming a thin stream of gas and dust. Other times, they erupt violently, reshaping the surface and releasing enormous amounts of material. From Earth, we can see only the results of these eruptions as bright streaks and glowing clouds. But spacecraft visiting comets have captured the dramatic beauty up close, revealing complex landscapes sculpted by the forces of sublimation. Despite the activity, comets are incredibly small compared to planets. A typical nucleus may be just a few kilometers wide, yet the tails can stretch millions of kilometers into space. The contrast between the tiny solid core and the vast luminous tails makes comets one of the most striking natural phenomena in the sky. Their fragile nature reminds us that they are temporary visitors, melting slowly as they approach the Sun, leaving behind trails of dust and gas that will continue to travel through the solar system long after the comet itself has faded. One of the most fascinating aspects of comet anatomy is the diversity we observe. Not all comets are the same. Some have smooth, rounded nuclei. Others are elongated or irregularly shaped. Some comets release gas and dust evenly across their surface, while others have strong, localized jets that erupt from specific points. Some develop bright, long tails visible even without a telescope, while others remain faint and nearly invisible, revealing their secrets only to sensitive instruments in space. Exploring a comet up close has revealed surprising details about their composition and activity. The European Space Agency's Rosetta mission visited Comet 67P Churyumov-Gerasimenko, following it as it travelled closer to the Sunday. Rosetta observed the formation of jets, the changing coma, and even measured the chemical composition of the nucleus. The lander, Philae, touched down gently on the surface, sending back images of rocky cliffs, smooth plains, and mysterious pits. These observations confirmed what scientists had long suspected. Comets are complex, dynamic worlds, small in size but rich in detail. The chemistry within a comet is also remarkable. Scientists have detected organic molecules, some of which are the building blocks of life, such as amino acids. They have found water ice, carbon monoxide, carbon dioxide, and ammonia. These substances suggest that comets are not just icy rocks, they are laboratories of chemistry, preserving the ingredients that may have helped life emerge on our planet. When a comet approaches the Sun, the heat releases these molecules into the coma, creating a delicate chemical display that drifts into space, potentially seeding other worlds over time. The movement of material from the nucleus to the coma and into the tails is a slow, graceful process. The comet rotates, causing jets to sweep across space like a lighthouse beam. The solar wind pushes the ion tail straight away from the Sun, while the dust tail drifts more slowly, curving along the path of the comet. This continuous, gentle interaction between the comet and its environment creates the dynamic and beautiful displays we see from Earth. Even the colors of comets are a quiet marvel. The blue of the ion tail is caused by gases glowing as they are energized by the Sun's ultraviolet light. The white and yellow of the dust tail is sunlight reflecting off tiny particles of rock and ice. Some comets, when observed with sensitive instruments, show hints of green or red caused by specific molecules in the coma. Each comet has its own palette, painted across the dark canvas of space, unique and fleeting. Despite their apparent simplicity, comets are among the most mysterious objects in the solar system. Their small size and fragile structure make them difficult to study. Many comets disappear after a single journey close to the Sun, leaving behind only faint traces of dust. Others survive multiple orbits, slowly changing as they lose material over centuries. Each comet carries a record of the early solar system, but the details of that record are locked away in ice, dust, and gas, revealed only to those who observe carefully and patiently. As we look closer at the anatomy of comets, we see the interplay of forces shaping them: gravity, sunlight, rotation, and the gentle push of the solar wind. These forces sculpt the surface, guide the tails, and create the jets that make comets so dynamic. Each feature, from the tiny nucleus to the vast ion tail, tells a story of motion, change, and delicate balance in the harsh environment of space. The anatomy of a comet is not static. As a comet travels toward the Sun, its appearance changes. The coma grows larger, the tails stretch farther, and new jets may appear. After passing the Sun, the comet cools, the coma shrinks, and it becomes quiet again, retreating to the darkness of space, sometimes never to return for thousands of years. This cycle of activity and calm is a quiet reminder of the fragility and wonder of these wandering worlds. Comets also interact with other celestial bodies. Some pass near planets, sometimes leaving trails of dust that will later create meteor showers on Earth. Others pass close enough to the Sun that they are torn apart by tidal forces, leaving fragments that drift silently through space. This interaction is gentle on the grand scale of the universe, but dramatic in its visual effect, creating beautiful, fleeting phenomena for those who watch carefully from Earth. Even with all we know, many questions remain. Why do some comets have irregular shapes? Why do some jets erupt strongly while others remain quiet? How much material do comets lose each time they pass the Sun? And how long can they survive in this fragile state? Each discovery leads to new mysteries, reminding us that comets are living laboratories of change, slowly revealing their secrets over time. As we conclude our close look at comet anatomy, we can appreciate the delicate balance of forces, materials, and processes that make these icy travelers so fascinating. From the frozen nucleus to the glowing coma and the sweeping tails, comets are small yet complex worlds, fragile yet full of cosmic beauty. They are reminders of the history of the solar system, the chemistry of life, and the ongoing dance of matter and energy across the universe. And yet, as remarkable as they are, comets are not confined to our solar system alone. Some wander from distant stars, carrying with them secrets of worlds we cannot yet reach. Others may bring materials that shape planets and perhaps even life itself. As we continue to follow these silent travelers, let us imagine drifting alongside a comet as it moves through the vastness of space. Each comet is on a journey that may last thousands, even millions of years. Their paths are shaped by the gravity of the sun and planets, by forces invisible to the eye, and by the quiet pull of distant stars. But how do these icy travelers decide where to go? How do they trace such intricate, looping paths across the darkness? Comets begin their lives in two main regions of our solar system. The first is the Kuiper Belt, a flat ring of icy bodies just beyond the orbit of Neptune. These objects are relatively close in astronomical terms, and some of them are nudged toward the inner solar system, becoming what we call short-period comets. These comets return again and again, orbiting the Sun in periods of less than 200 years. Halley's Comet, though slightly farther out, is a well-known example, visiting the skies of Earth like clockwork every 76 years. The second, more distant source is the Oort cloud, a spherical shell of icy objects stretching nearly a light-year from the Sunday. This is a place of extreme cold and silence, a dark frontier where comets drift slowly, undisturbed for eons. Occasionally, a small disturbance, the gravity of a passing star, or the motion of a nearby cloud of gas, nudges a comet inward, sending it on a long, dramatic journey toward the Sunday. Some of these comets take thousands or even millions of years to complete their orbit, returning only once in human history. Can you imagine a world that travels so slowly that no one alive today will ever see it again? As a comet begins its journey inward, the sun's warmth awakens it from its deep freeze. Ice begins to vaporize, and the coma forms, spreading a delicate glow across space. But the journey is not simple. Comets do not move in straight lines. Gravity bends their paths, curving them around planets, pulling them into elongated ellipses, or sometimes flinging them back toward the distant darkness. Some comets are captured into short, looping orbits. Others are given a final, hyperbolic path, hurtling them out of the solar system forever. Have you ever wondered what it would feel like to ride along one of these paths, gliding past planets and through sunlight without ever slowing down? The orbits of comets are full of surprises. Some follow nearly circular paths, like familiar planets, while others are long and narrow, sweeping in from the edges of space and diving close to the sun before retreating again. Short-period comets, like Encke or Halley, return many times, giving astronomers the chance to study them repeatedly. Long-period comets may appear once and then vanish, leaving only a trail of dust in their wake. The idea that some comets visit only once is both humbling and intriguing. What secrets might they carry that we may never discover? Sometimes, comets take on paths that seem to break the rules of our solar system entirely. In 2017, scientists observed ʻOumuamua, an object moving on a hyperbolic orbit, coming from beyond the Sun's gravitational pull. Unlike comets we know, it did not have a bright tail at first, and its elongated shape puzzled astronomers. 2 years later, 2I Borisov arrived, a more traditional comet, yet still interstellar. These visitors remind us that the universe is far bigger than we can imagine. How many more travelers from distant stars are drifting silently toward us, carrying stories of worlds we cannot yet see? The journeys of comets are also marked by encounters with planets. As they move inward, their paths may bring them close to Jupiter, Saturn, or even Earth. The gravity of these giants can alter the comet's orbit dramatically, bending it closer or hurling it away. Some comets pass near enough to leave behind streams of dust, which later produce meteor showers visible on our night sky. Every streak of light in a Perseid or Leonid shower is the quiet fingerprint of a comet that passed years or even centuries before. Do we ever pause to consider that each falling star we see might be a fragment of a comet that traveled millions of kilometers across the solar system? Comet journeys are not just about travel, they are about change. As comets approach the Sun, their icy surfaces sublimate, releasing gas and dust. Jets erupt from specific regions, shaping the comet and sometimes altering its rotation. Some comets split apart, breaking into pieces that continue along slightly different paths. Their delicate structure makes them vulnerable, yet this vulnerability creates spectacular displays for those who observe them from Earth. Could it be that their fragility is part of their beauty, a reminder that even in space, nothing lasts forever? Even the simplest orbit hides complexity. A comet's rotation, shape, and surface features all influence how it moves and how it reacts to sunlight. Some comets spin slowly, letting sunlight evenly warm the surface. Others tumble erratically, creating sudden bursts of activity. Tiny forces, like the outgassing of sublimated ice, can slightly push the comet, altering its trajectory over time. Imagine a tiny world, moving silently across millions of kilometers, subtly guided by the gentle thrust of its own outgassing. How many secrets are encoded in these quiet motions, invisible to the naked eye? As we follow a comet inward, we notice that its tail becomes longer, stretching millions of kilometers behind it. The dust tail curves along the orbit, while the ion tail streams straight away from the Sun, glowing softly in blue. These tails are more than decoration. They are evidence of the comet's interaction with the Sun, the solar wind, and the environment of the inner solar system. Each tail tells a story, a record of the comet's journey and its response to the forces around it. What patterns might these tails reveal to astronomers who study them closely? What hidden messages lie in the dust and gas trailing behind? The paths of comets are also connected to time. A short-period comet like Halley returns frequently, but long-period comets arrive on timescales far beyond a human lifetime. Some may have started their journey before the first humans walked on Earth. Some may not return until centuries after the last human story is told. There is something humbling about this, a reminder of the immense scale of the universe and the quiet persistence of these travelers. What wonders have they seen along the way? What secrets of distant space have they carried silently across the dark? While most comets stay within the gravitational influence of the Sun, some are on escape trajectories, leaving the solar system entirely. These hyperbolic comets may never return, becoming interstellar wanderers. Their journeys remind us that the cosmos is alive with motion and mystery, with worlds traveling vast distances, unseen, carrying unknown stories. If a comet can travel beyond the reach of our Sun, what other travelers drift silently among the stars, waiting to be discovered? Even as we watch from Earth, we only see a tiny portion of a comet's journey. We see the glow of the coma, the sweep of the tails, and the occasional streak across the night sky. But beyond our vision, comets are moving through space at incredible speeds, sometimes hundreds of thousands of kilometers per hour. They pass near planets, collide with dust clouds, and continue onward toward the distant darkness. Each journey is unique, a combination of cosmic forces, chance encounters, and the slow, steady push of their own outgassing. What stories are written in these paths, hidden from view, waiting for us to uncover them? The beauty of comet journeys is that they are never truly predictable. Scientists can calculate their paths with precision, but the activity on the comet itself, the jets, eruptions, and subtle forces, can alter the course over time. Comets are living histories, slowly changing as they travel. Some may brighten unexpectedly, creating spectacular shows in the sky. Others may fade quietly, leaving only a faint trail of dust. Can we ever predict the full story of a comet's journey, or will some secrets always remain beyond our reach? As we follow these journeys, we begin to see comets not just as icy objects, but as storytellers. Each one carries a message from the edges of the solar system, from the birth of the planets, or from distant stars. Their paths weave through the universe, interacting with planets, dust clouds, and sunlight, leaving traces of their passage for us to observe. The journey of a comet is a journey through time, as well as space, a slow, gentle dance that spans millions of kilometers and thousands of years. What messages might these travelers carry? What wonders might they reveal if we learn to read their trails carefully? In the silence of space, the journey of a comet is both quiet and dramatic. It moves with purpose, yet it is subject to forces beyond its control. Gravity shapes its path, the sun warms its surface, and jets of gas and dust push it in subtle ways. Each comet is a unique traveler, its journey marked by change, interaction, and beauty. Some may return to the outer solar system, while others will continue inward, perhaps even passing close to Earth. Will we ever catch all the stories they carry? Or will some journeys remain mysteries, hidden in the darkness of space? As we continue to watch the comet drift through the solar system, we notice how its tail dances in the sunlight, how the coma glows softly, and how the nucleus spins gently in space. Its journey is far from over. There are still mysteries to uncover, questions to ask, and phenomena to observe. What happens when a comet passes very close to the Sun? How do these journeys affect the comet's structure, activity, and ultimate fate? These are questions that will guide us as we continue to explore these fascinating celestial travelers. The journey of a comet is not just a story of motion, it is a story of life, change, and cosmic interaction. As it moves through the solar system, it leaves behind traces of its passage, interacts with planets, and occasionally offers us a glimpse of its ancient secrets. These silent travelers remind us of the vastness of space, the fragility of small worlds, and the wonders that await those who look up at the night sky with curiosity. And as we watch, we are left wondering, what will the next comet bring? Will it shine brightly across the sky, or drift quietly, nearly invisible? Will it carry new secrets from the distant reaches of space, or tell the story of our own solar system in ways we have yet to imagine? As we follow the silent journeys of comets through the vast reaches of space, we begin to notice how their paths sometimes bring them closer to Earth. From these encounters, comets do not merely pass by, they leave traces, impressions, and even stories behind. They are travelers that connect the distant reaches of the solar system with our planet, reminding us that Earth is part of a much larger cosmic web. When a comet approaches the inner solar system, it begins to shed dust and small fragments along its orbit. These fragments, invisible to the naked eye, slowly spread out, forming trails that linger for centuries. When Earth crosses one of these trails, tiny particles enter our atmosphere, burning up and producing the glowing streaks we call meteor showers. Perhaps you have seen the Perseids in August, or the Leonids in November. Each flash of light is a small fragment of a comet, travelling at incredible speed, yet disappearing in a burst of fiery beauty. Can you imagine that each streak of light once belonged to a comet millions of kilometers away, drifting silently before finally reaching us? Meteor showers are more than just beautiful events. They are reminders of the dynamic relationship between comets and our planet. These showers occur annually, as Earth passes through the same cometary trails again and again. In this way, comets leave a lasting mark on our skies, long after they have passed. Comets or fragments may pass close enough to Earth to pose a real physical impact. While large impacts are extremely rare, history reminds us that they are possible. The collision of a comet or asteroid could release energy far greater than any volcano or earthquake. This is one reason why astronomers carefully monitor the orbits of comets that come near our planet to understand their paths and predict potential encounters. What would happen if a comet struck Earth? Could a single fragment change life on our planet forever, or is it more likely that we are safe in the quiet vastness of space? Even without direct collisions, comets leave traces on our world. Tiny particles that survive their fiery entry into the atmosphere can land on Earth as micrometeorites. These dust grains carry information about the composition of the comet and the early solar system. Scientists study them to understand not only the structure of comets, but also the history of our own planet. It is remarkable to think that these small, almost invisible particles have traveled billions of kilometers, survived entry through the atmosphere, and now rest quietly on Earth, holding secrets from the edge of space. How many of these silent travelers are already resting on Earth, waiting for us to discover their story? Comets also shape our understanding of the solar system. Observing their orbits and paths has allowed astronomers to calculate the gravitational influence of planets, understand the structure of the Kuiper belt and Oort cloud, and trace the history of the solar system itself. Every comet that passes near Earth offers an opportunity to study the universe in action. Even their unpredictable changes, sudden brightening, splitting, or loss of material, provide valuable lessons about the forces at work in space. What might future observations reveal about the hidden mechanisms guiding these wandering worlds? Cultural and scientific history intertwine in the study of comets. For centuries, their appearances were mysterious, unpredictable, and often terrifying. Bright comets were recorded as omens before battles, signs of disease, or portents of great change. Yet, with the rise of modern astronomy, we began to understand these events not as warnings, but as natural phenomena, objects following paths determined by gravity and physics. This shift changed our relationship with the sky. We went from fearing comets to studying them, observing them carefully, and even sending spacecraft to meet them. How did humanity's understanding of these visitors evolve over time, and what mysteries remain even today? The Rosetta mission, which followed Comet 67P Churyumov-Gerasimenko, brought these distant worlds even closer. By studying the comet in detail, scientists observed how comets release gas and dust, how jets erupt from the nucleus, and how these processes affect the comet's path. Rosetta revealed that comets are not static, they are living, dynamic objects interacting with their environment and leaving traces of their journey. The same principles apply to comets passing near Earth. Every journey is a story of motion, change, and interaction. What new phenomena might future missions uncover, and how will these observations deepen our connection to comets? Bright comets are also rare gifts for observers on Earth. When a comet is close enough and large enough, Its tail can stretch across the sky, glowing with a gentle light visible even without a telescope. These events are fleeting, sometimes lasting only a few weeks, but they leave lasting memories for those who witness them. Imagine standing under a clear, dark sky, watching a comet's tail sweep across the stars, a reminder of the vast distances it has traveled. What emotions did ancient observers feel when they saw these bright visitors for the first time? And how does it feel to witness the same phenomenon in the modern age, knowing the science behind it? Comets also interact with Earth in subtle ways. Their debris, tiny dust grains, and molecules enter the atmosphere, some falling to the surface. Over millions of years, this constant rain of material may have influenced Earth's chemistry. Some scientists suggest that cometary material could even contribute to the building blocks of life, delivering organic molecules that slowly accumulated on our planet. Could these silent, icy travelers be connected to the story of life on Earth, linking the cosmos to the very molecules that make us who we are? Human curiosity has always followed the paths of comets. Observatories around the world monitor comets as they approach, using telescopes and spectrometers to analyze the light they reflect. These observations reveal their composition, their speed, and their activity. Amateur astronomers also contribute, capturing images and tracking comets over months and years. In this way, comets continue to connect people with the universe, inspiring awe, wonder, and a sense of cosmic perspective. How many comets are silently approaching the inner solar system now, waiting for us to discover them? Throughout history, comets have inspired stories, myths, and art. From Chinese records to European chronicles, from the writings of ancient philosophers to modern documentaries, comets have captured human imagination. They are symbols of change, mystery, and beauty. Yet behind these stories lies science, the physical reality of icy bodies traveling millions of kilometers, shedding dust, forming tails, and occasionally visiting Earth. What other stories might comets inspire in the future as we continue to observe and explore them? Even the smallest encounters can leave a lasting impact. A fragment of a comet may enter Earth's atmosphere unnoticed, or a bright comet may appear for a few weeks and then vanish. In every case, these events remind us of the dynamic relationship between Earth and the rest of the solar system. They teach us that our planet is not isolated. It exists within a network of cosmic forces and wandering worlds, each following its own path. What new discoveries await as we continue to study comets and their influence on Earth? As we watch comets pass by, we realize that their relationship with our planet is both ancient and ongoing. They bring beauty, mystery, and science. They remind us of the vastness of space, the fragility of our world, and the connections that stretch across the solar system. Every meteor shower, every bright tail, every fragment that enters our atmosphere is a silent story, a cosmic message delivered across millions of kilometers. Could there be messages yet unread, hidden in the dust and ice of comets, waiting for us to decipher? From meteor showers to bright comets streaking across the sky, the evidence of these icy visitors is all around us. They are reminders of the vast solar system, of the forces that shape our world, and of the beauty and mystery that exist beyond our planet. They leave traces, records, and even possibilities, quietly connecting Earth to the distant edges of the solar system and beyond. What wonders will the next comet reveal as it approaches Earth? What stories will its journey tell? And how will it inspire future generations? And so, as we gaze at the night sky, we can imagine comets drifting silently through space, leaving trails of dust, light, and history in their wake. They are reminders that the universe is alive with motion, mystery, and beauty, and that even distant worlds can touch our own. The journey of comets continues, and we are fortunate to witness just a small part of it as Earth and Comet meet in the quiet dance of the cosmos. As we journey further into the cosmos, we encounter travelers unlike any other, comets that have not formed in our solar system, but have drifted across the vast stretches of interstellar space. These are the rare interstellar comets, visitors from afar that carry with them secrets of distant stars and unknown worlds. The first such object ever detected was ʻOumuamua, discovered in October 2017. Its name, meaning scout in Hawaiian, reflects the sense of wonder it inspired. ʻOumuamua was unlike any comet or asteroid astronomers had seen before. Its long, cigar-like shape and lack of a visible coma puzzled scientists. Most comets we know develop a glowing cloud of gas and dust as they approach the Sun. Yet ʻOumuamua appeared inert, more like a rock than a traditional icy comet. Adding to the mystery, it exhibited slight acceleration as it left the solar system, suggesting forces at work that were difficult to explain. Could it be venting gas too faint to detect? Or might there be other, more exotic explanations? 2 years later, in August 2019, a second interstellar visitor arrived, 2I Borisov. Unlike ʻOumuamua, Borisov resembled a more traditional comet with a bright coma and a long, visible tail. It showed evidence of water ice and other common cometary gases. Still, it travelled on a hyperbolic path, meaning it was not bound to the Sun and had originated far beyond our solar system. By studying 2I Borisov, astronomers could compare it to comets from our own neighbourhood, noticing differences in chemical composition and activity. This comparison reinforced the idea that interstellar comets can vary widely, just as planets and stars do in the galaxy. What makes these interstellar visitors truly fascinating is how different they are from typical solar system comets. Most comets in our own system originate from either the Kuiper belt, just beyond Neptune, or the distant Oort cloud. These comets usually follow predictable elliptical orbits and contain mixtures of ice, dust, and organic molecules shaped by the environment of our solar system. Interstellar comets, however, carry materials and structures shaped in entirely foreign systems, perhaps orbiting stars that are billions of years older or younger than our Sunday. Their chemical composition, shapes, and behaviours can be profoundly different. For example, ʻOumuamua's elongated shape and unusual rotation puzzled astronomers. It was tumbling end over end, a motion rarely seen in solar system comets. Its trajectory showed small but persistent acceleration, unexplained by gravitational forces alone. Some scientists suggested it might be venting gas in a way too faint to detect. Others, more controversially, speculated about artificial origins, though no evidence confirmed this. Regardless, ʻOumuamua taught us that interstellar objects can challenge everything we know about cometary physics. 2I Borisov, in contrast, behaved more like a typical comet but still showed subtle differences. Its chemical composition had slightly higher amounts of certain gases compared to solar system comets. Its dust and ice mixture indicated that even familiar-looking comets from other systems can carry surprises. These differences tell us that the processes that form comets can vary widely across the galaxy. The study of these interstellar visitors has opened our eyes to the possibilities of the future. It is almost certain that more interstellar comets will visit our solar system. With new surveys, improved telescopes, and advanced space missions, astronomers are now capable of detecting these objects earlier and observing them more closely. Each new visitor may provide insights into planetary systems far beyond our own, carrying clues about the formation of stars, the prevalence of water and organic molecules, and perhaps even the conditions that could give rise to life. Occasionally, a new discovery joins this small but growing family, 3I Atlas. Discovered on the 1st of July 2025 by the Atlas telescope in Chile, 3I Atlas is only the third confirmed interstellar object to enter our solar system, following ʻOumuamua in 2017 and 2I Borisov in 2019. Its discovery was a momentous occasion, as such visitors are exceedingly rare. But what makes 3I Atlas even more remarkable is its size. Estimated to weigh over 33 billion tons, and with a nucleus diameter exceeding 3.1 miles, 5 kilometers, it is potentially the largest known interstellar object ever observed. Unlike typical comets that originate from the Kuiper belt or Oort cloud, 3I Atlas's journey began in another star system. Its trajectory suggests it has been traveling for billions of years, possibly from a distant region of the Milky Way. As it approaches our Sun, it begins to heat up, releasing gas and dust, forming a glowing coma and a tail, a spectacle visible to astronomers on Earth. But what secrets does this visitor carry from its distant home? What can its composition tell us about the conditions of other star systems? The comet's closest approach to Earth will occur in mid-December 2025, when it will pass at a safe distance of approximately 170 million miles, 270 million kilometers. NASA science. While it poses no threat to our planet, its visit offers a unique opportunity to study an object from another star system up close. In the coming months, as 3I Atlas moves away from the Sun, it will become more challenging to observe, but the data collected during its visit will continue to provide valuable insights for years to come. And who knows, perhaps this won't be the last time we encounter a visitor from the stars. The mysteries of these visitors remain unsolved. Why do they sometimes behave in unexpected ways, like the acceleration of ʻOumuamua? What can their shapes and chemical makeup reveal about the diversity of planetary systems? How common are these objects, and what secrets might they carry from stars far beyond our Sun? Even as we observe them with the most sophisticated instruments, each interstellar comet leaves us with more questions than answers. Looking to the future, scientists anticipate that more interstellar comets will be discovered. The Vera Rubin Observatory, set to come online soon, promises to detect fainter and faster moving objects. With each new discovery, we will expand our understanding of how comets form, evolve, and travel across the galaxy. Could some of these comets carry prebiotic molecules, or even the building blocks of life across interstellar distances? Could they tell us stories of planets orbiting stars we may never see directly? As night falls over Earth and we gaze at the stars, it is humbling to realize that objects like ʻOumuamua, 2I Borisov, and 3I Atlas are not just passing curiosities. They are cosmic messengers, carrying materials, histories, and perhaps even hints of life from distant systems. They invite us to imagine the countless worlds beyond our own, and to wonder about the unseen forces shaping the galaxy. What other secrets might these travelers hold? What will the next interstellar visitor reveal? And how will our understanding of the universe expand as we continue to encounter them? Interstellar comets remind us that our solar system is not isolated. It is part of a dynamic, interconnected galaxy where icy travelers silently drift between stars, each carrying the potential to expand our knowledge and spark our imagination. As we continue to watch the skies, we are not merely observing comets, we are witnessing the stories of distant worlds, whispered across the vastness of space, waiting for us to listen. While comets drift silently through space, their close encounters with spacecraft and planets have brought them remarkably close to our understanding. Studying comets up close has revealed astonishing details about their composition, behavior, and the history of our solar system. One of the most famous missions was ESA's Rosetta, launched in 2004. Rosetta traveled for over 10 years through space to meet Comet 67P, Churyumov-Gerasimenko, a small, irregularly shaped comet. In 2014, it became the first spacecraft to orbit a comet. Shortly afterward, Rosetta deployed the Philae lander, which touched down on the comet's surface. Though the landing was bumpy and Philae bounced across the surface, it successfully transmitted data back to Earth, providing a close-up view of a comet for the first time. From Rosetta and Philae, we learned that comets are far from solid rocks or smooth spheres. Their surfaces are covered in dark, dusty layers with cliffs, pits, and boulders. Comets are surprisingly soft in some areas, almost like a frozen sponge, and they release gas and dust in jets that can reshape their surface over time. Instruments detected water ice, carbon monoxide, carbon dioxide, and organic molecules, complex building blocks that may have contributed to life on Earth. Rosetta also revealed surprising sensory details about comets. Some scientists described their smell as similar to burnt almonds or rotten eggs, likely from organic chemicals released as the comet warmed. The texture of the comet's surface was uneven, with fine dust, rough rocks, and softer ice patches. Watching the jets erupt as the comet approached the Sun was mesmerizing. These active processes show that comets are dynamic worlds, constantly changing, not frozen relics as once imagined. Comets have also made dramatic appearances in our solar system without the help of spacecraft. Comet Shoemaker-Levy 9 famously collided with Jupiter in 1994. The comet had broken into fragments, which plummeted into Jupiter's thick atmosphere, creating massive fireballs and dark scars larger than Earth itself. Observing this event taught astronomers about the power of comets and the potential effects of collisions in the solar system. It also offered insight into how comets can deliver energy, material, and even water to planets. Studying comets up close allows us to understand not just what they are made of, but how they behave. We see how their irregular shapes, low gravity, and spinning motion influence the way gas and dust are released. We observe seasonal changes as different areas of the comet are illuminated by the sunday. We also learn how comets evolve over time, gradually losing material with each orbit, leaving behind trails of debris that later become meteor showers on Earth. Each close encounter brings surprises. Comets are not uniform. They have strange shapes like rubber ducks, elongated lobes, or jagged surfaces. Some regions are soft and porous, others are hard and rocky. Jets erupt from unexpected areas, and dust storms can blanket large portions of the surface. Even the smallest details, tiny ice crystals, the color of dust, or the faint smell of organic molecules, tell a story about the origins of the solar system and the materials that existed billions of years ago. Missions like Rosetta remind us that comets are not distant, unchanging objects. They are active, evolving worlds with textures, smells, and motions that defy our expectation. By observing them closely, we gain a deeper appreciation of their complexity and their role in the cosmic dance of our solar system. As we continue to explore, new missions are being planned to visit more comets, sample their surfaces, and even return material to Earth. Each mission brings us closer to understanding these mysterious travelers, their history, and perhaps the secrets they hold about the origins of life. Even as we study comets from afar, Imagining them erupting jets of gas or spinning silently through space, we are reminded of their mystery. They are ancient messengers, carrying clues from the very edges of our solar system, waiting for humanity to unlock their secrets. And as we look forward to the next comet to be visited, we are left with a quiet question. What will this small, icy traveler reveal to us about the universe and our place within it? As our journey with comets continues, we look toward the future, toward the missions, instruments, and discoveries that await us. New telescopes, like the Vera Rubin Observatory, promise to detect comets earlier and track them with unprecedented precision. Space agencies are planning missions to visit, orbit, and even return samples from comets, allowing us to study their ice, dust, and organic materials in ways never before possible. Each mission brings the hope of answers to the oldest questions in science. How did our solar system form? How do comets carry the building blocks of life across the cosmos? Interstellar comets like ʻOumuamua, 2I Borisov, and 3I Atlas remind us that the galaxy is full of wandering travelers, each with a story billions of years in the making. By studying these visitors, scientists hope to understand the chemical richness of distant star systems and the processes that shape planets, comets, and possibly life itself. They carry materials forged in alien worlds, offering clues about interstellar chemistry and the diversity of planetary systems. Yet comets inspire more than just scientific discovery. Their mysterious shapes, glowing tails, and quiet journeys through the darkness of space stir the imagination. Artists, writers, and dreamers have long been captivated by their beauty, drawing from their fleeting brilliance to create works that celebrate the wonder of the universe. Even now, as we peer through telescopes, their silent passage sparks curiosity and awe, reminding us that the cosmos is alive with motion, color, and history. These icy travelers are, in many ways, time capsules. They preserve ancient material from the earliest days of star and planet formation. Each grain of dust, each frozen molecule, is a messenger from a time before Earth existed. By studying them, we glimpse the conditions that existed billions of years ago, connecting us to the story of our own planet and the greater galaxy. And as we gaze at the night sky, we are reminded of their quiet, ceaseless journeys. Comets continue to drift through the solar system and beyond, invisible to most eyes, yet carrying secrets yet to be revealed. What messages do they hold about distant stars? What histories are written in their ice and dust? Perhaps some carry prebiotic molecules, seeds of life, or simply stories of the stars they have visited. In this silence lies beauty. In their icy, ephemeral trails, there is a gentle reminder of our place in the cosmos. Comets teach us patience, curiosity, and wonder. They are cosmic messengers, ancient travelers, and keepers of secrets. They invite us to look up, to imagine, and to consider the vastness of time and space. As we close this chapter of exploration, we leave with a sense of peace, gazing at the sky and imagining the countless comets moving silently, waiting for their turn to share their stories. Their journey continues, and so does ours, watching, learning, and marveling at the universe we call home. Good night, and may your dreams be filled with wonder.